Okay, another topic you have to cover on paper 2 is coordinate geometry of the line. Right? In terms of the line, you have to be able to plot points on your Cartesian plane, so plotting your points out using your x and y axis. You have to get the distance between 2 points, which can also be asked as the length between the 2 points. You need to be able to calculate the midpoint between the two values that they give you, the slope of the line, an equation of a line, intersection between two lines, or possibly a line and a circle when you're doing the circle, and how to find the area of the triangle. Okay, so again, these will normally appear on paper 2, so we're going to cover them step by step. Alright, so in terms of the first bit, if you get asked how to plot points on your Cartesian plane, you just have to remember you have to go out the x value, so the first number in your brackets is your x, so you go out that, and then you go up and down your y value, right? And we will do a few examples of them in a minute, but we're going to do distance between 2 points. In terms of distance between 2 points, if they've given you the points, what you have to do is label the points, and you're labeling the points x1, y1, x2, y2. In terms of labeling, the points have to go from the left-hand side of the page to the right-hand side of the page. Okay? So label your points, write down the formula. Your formula you find in the log tables, and it is a square root sign with y2 minus y1 in brackets to be squared, plus x2 minus x1 in brackets to be squared. So after you've labelled your points, plug the points into your formula and then solve. Okay, but don't just plug them in and solve in the one step, because if you do something wrong, you will lose marks. Alright, so I'm just going to jump to the book so you can see examples. Right, so in your text and test, it says, show that the point D2, D2, comma 4 is equidistant between E, which is minus 5, 1, and F, 5, minus 3. So in terms of what they've done, they've plotted the points first. So your D was 2, 4, so you would have gone out 2 for your X value and up 4, and this would be your D. For your E, you went out minus 5, so you went back this way minus 5, and you went up 1. And for your F, you went out 5 because it was positive, and then down 3 because it was a negative 3. You want to show that it's equidistant, so you're going to get the distance between those points. So how are you going to do it? According to my little method I had written down. Is you write your points down. So I have 2, 4, minus 5, 1, and 5, minus 3, and that's D, and that's E, and that's F. Okay, so there are my points. I want to get the length between them, or the distance. So method is label your points. So you can only do 2 at a time. So that's x1, and that's y1, and that's x2, and that's y2. Write down your formula. The formula was a square root sign. y2 minus y1 squared plus x2 minus x1 squared. Plug them in. So you're going y2, so you have your square root sign. Don't forget to write it down because lots of students love leaving that out. So you're going bracket 1, take away 4 squared plus minus 5 take away 2 squared. Right? So I've plugged them in, I haven't solved them yet, and then you solve them. So when you're solving them, remember to take into account your normal algebra rules. So we've got positive 1, take away 4, so the take away 4 is bigger, so your answer in there is negative 3. And here we've 2 negative signs, so we've got a negative 5 and a negative 2, so that will give us negative 7. Right? But they are being squared, so when they are being squared, the 2 negatives will cancel each other out in the square, so we get plus 9 and plus 49, so you get the square root of 58. So the distance between the point D and the point E was root 58. We also want to find out the point D to F. So again, same idea. You'd label it, so x1, y1, and this time this is x2, y2. Again, you'd write down your formula, and then you plug them in. So we're pretending this doesn't exist anymore. So you're going y2, so we have a bracket, minus 3 minus 4 squared, plus 5 take away 2 squared. Okay? So you just plug them in. You haven't messed with them yet. Then do your solving. So minus 3 minus 4 will give you a negative 7, or minus 7. 5 take away 2 will give you a positive 3. Okay? And then you're squaring them. So when you're squaring them, you get 49 and 9, and that's all under your square root sign. So you get that the distance between that is equal to 58. So in the example, we have shown that 58 and root 58, they're the same. Okay. Another example. It's again from the book, question 5 on page 53. I'll show it to you here. It says A is 1, 1, B is 3, 6, and C is 5, 1 are the vertices of a triangle. That means they're the corners of a triangle. Show that straight line AB is equal to straight line BC. So that means the length from A to B is equal to the length from B to C. So we'll do that as an example. So we want to get the distance from A to B. So our point A was 1, 1. Our point B is 3, 6. So you write your points down. You label your points. So x1, y1, x2, y2. Write down your formula. So you've got y2 minus y1 squared plus x2 minus x1 squared. Plug the values in, remembering your square root sign. So we have 6 take away 1 squared plus 3 take away 1 squared. So again, remember, y2 is over here. Taking into account your algebra, so 6 take away 1 gives you 5. 3 take away 1 gives you 2. So in this case, we are getting 25 and 4. So the length from A to B is root 29. We also want to get the distance from B to C. So you'd write down what B was. So B is 3, 6, and C is 5, 1. So again, write the point down, label them. So again, this is x1, y1, and this is x2, y2. For our first part, we had this label as x2, y2. It's a totally new part of the sum, so you relabel them as your x1s and y1s. So label them. Sorry, I dropped my pen. Write the formula down. So y2 minus y1 squared, x2 minus x1 squared. Plug in your value. So y2 in this case is 1. So we're going 1, take away 6 squared, plus 5, take away 3 squared. So 1 take away 6, or 6 is bigger here, so we're actually ending up with a minus 5. 5 take away 3 is a normal subtraction, so it's just 2. So when we work that out, we are getting the square root of 25 plus 4, which is root 29. And then we have realized that root 29 and root 29 are both the same. Okay, so that's how you get the distance between 2 points. So again, method-wise, write down your point, label your point x1, y1, x2, y2, write down your formula, plug it into your formula, then solve it. Okay?